I'm Alan Johnson, KU2Y, and this is step 7 for the CubeSat simulator, soldering and testing the solar panels. So we're going to need a soldering iron, and you should always use a safety glasses when you're doing that. I have my solder, I have my metal curls for cleaning the tip. Also, you might need a flux pen. It's helpful for if you have difficulty soldering on the panels themselves. Also, we're going to be using a hot glue gun to secure the wires. And finally, for testing them, we're going to be using a digital multimeter. Okay, so here are the 10 solar panels that we're going to be using. And these solar panels, they have some plastic on them. So you should start by peeling that plastic off. There you go. And on the back, you can see the plus and minus. And we're going to be using our 10 JST2 connectors here. Now, one thing, before you use these, make sure that the polarity is correct, because unfortunately some of them that you buy have red and black swapped. So the things to look at, notice that in this case the top side has the little tab on it, and if I look on the opposite side of the tab, so here's the side with the tab, here's the underneath, and you see red is on the left and black is on the right. If they are reversed, it is possible to reverse them. There's these little tabs here. You can press on the tab and swap the wires, or maybe you just get a new set of these. As I said, unfortunately, I have bought them both ways. Okay, so let's get started here. So I'm just going to take these one at a time and solder them. And typically just use something to hold the wire so that it doesn't move. The other way, and if you are going to use liquid flux, you can just put a spot of liquid flux on either side. And if we do that, we can add a blob of solder to each, and then we can solder black and the red lead, and that is it. Try this one without the liquid flux. These look pretty clean. Yeah, there's no issue here. I don't need the liquid flux on these ones, but sometimes it's a help. So I'm gonna get all the other ones ready here too. Okay, so they're all ready now. And I just need to pay attention to make sure the red goes to the plus and the black goes to the negative. So I just need to finish all 10 solar panels. And then we will test the solar panels with our digital multimeter. Also, I'm going to use the glue gun. Oops. And the glue gun is going to attach, it's going to attach the insulation, the plastic part of the wire, to the solar panel, and that way provide what's known as strain relief, so that when you pull on the leads, as will inevitably happen, instead of it pulling directly on the solder connection itself, which could either break the connection or it could possibly peel the trace off the back of the solar panel and damage it, instead it will pull on the insulation, and that way we'll save breakage and damage. Okay, so that looks good. So now I've got my hot glue gun here. So let me do these. So what I'm going to do is I'm going to lift up the wires here, and this is I've had this heating up, so it's warm, and I've got glue in there, and I'm going to force it basically underneath, and then I'm going to push it down. That's a little messy, but you get the idea. I'll show you one that I do a little nicer here. So I kind of lift it up, put it so the glue goes underneath, and then put some glue on top. Let's see if that's a good one there. Yeah, that one's pretty good. And the trick is keep the glue off of the pad, so that way you can resolder them without getting the hot glue on your iron. But it's still, you can see when you pull on that, it's a lot stronger than it was before. Okay, let's do the rest of them here. Also, try not to put too much glue, because it can sometimes cause the panels to not sit straight. Also, be careful, the hot glue is hot, and it will stick to your finger and burn your finger if you're not careful. Okay, a few more to go. Okay. So these solar panels are finished. Now let's just do a little testing here. So here's my digital multimeter. I'm going to set it to DC volts. And the easiest way to measure is to just press on the back here. So for example, if I do red to red and black to black, and you see I record a very small voltage. The reason, oops, make it so you can see better. Go. Reading a very small voltage there. And the reason for that, of course, is that the panel is facing down. So let's flip it over. So now the panel is getting some light. Now it's a little bit trickier, but it is possible to push down on the backs of these leads here, like so. There we go, 3.5 volts. That's quite reasonable for just a little bit of illumination. In the sun, these would read 6 volts or higher. Okay, so that's called the open circuit voltage. It just tells you the maximum voltage that it will read under illumination. Now, to measure the current, we switch this to, I'm going to switch it to milliamps DC. So now my current meter is in milliamps. With some meters, you also need to move the connections, but I don't need to on this one. And so now the meter acts like a very low resistance, basically acts like a small resistance. So it acts like a short circuit. So when I put it across here, same way as before. Now I'm going to get a reading of the short circuit current, which is the maximum current that we can get. Pretty small. Maybe I'll switch it to microamps here, since the illumination is not very strong. There we go. So about 100 microamps, so 0.1 of a milliamp is all we're getting here. In the sun, the maximum for these panels is about 60 milliamps. Okay, so that completes the assembly and testing of our solar panels, which are now ready to be mounted on the frame.